Good morning, students. Now, in the last lectures, we have seen about progressions, and there are some more problems based on progressions that I will be taking up once our offline classes start. Right? Now, in the previous lectures, what we have done is some simple based examples, formula based examples. Right? So, from today, I will be starting with a new chapter and in coordinate geometry. I am going to start with coordinate geometry now. Now in this coordinate geometry, the chapters that you are going to study in this coordinate geometry, the chapters that you are going to study are straight lines and conic sections. Straight lines and conic sections. So the first one that we are going to study will be about straight lines. The first one that we are going to study is about straight lines. Now in this straight lines, before we start with straight lines, let me remind of what you have studied till SSLC, because those formulas will be continued here also. Right? Now, simple introduction of the coordinate system. In this coordinate system, remember, you are going to have four quadrants. That is here, it is the first quadrant, this will be the second quadrant, this is going to be the third quadrant, and this is going to be the fourth quadrant. This you all know. And you are having two axes that we call it as the x-axis and the y-axis. In the first quadrant, x is positive as well as y is positive. X will be positive as well as y will be positive. In the second quadrant, x is negative, y is positive. In the second quadrant, you know that x will be positive and y will be in the second quadrant, x is negative and y is positive. In the third quadrant, both the axes will be negative. Both the axes will be negative in the third quadrant. And in the fourth quadrant, x is positive and y is negative. Whenever you want to denote any point in this coordinate system, we call this coordinate system as the rectangular coordinate system. We call this as the rectangular coordinate system. So whenever you want to write any part in this coordinate system, the first one you are always going to write about the x-axis, and the second point you are always going to write about the y-axis. These are the things that you will be noting here. Now, the point of intersection of these two axes, you always call it as the origin, that is O. The point of intersection of these two axes, you always call it to be the origin O. Now, you have studied some of the formulas. Now, if x1, y1 in point, first I am going to consider this in the first quadrant only for your easy reference. If x1, y1 and x2, y2 are any 2 points in this rectangular system, then you know that if I want to find the distance between any 2 points here, if I want to find the distance between any 2 points, say the first point is A and the second point is B. The first point is A and the second point will be B here. Then the distance between these 2 points is given by the distance formula that we call. We call it as the distance formula, and it is given by AB is equals to root of x2 minus x1 the bracket square plus y2 minus y1 the bracket square. This is the distance formula, what we call it as. So the distance formula is given by what? AB is equals to root of x2 minus x1 the bracket square plus y2 minus y1 the bracket square. The same formula can also be written as root of x1 minus x2 the bracket square plus y1 minus y2 the bracket square. This will be the distance formula. You can write this distance formula as in any one of the forms. You can write the distance formula in any one of the points. So here AB is equals to what? Root of x2 minus x1 the bracket square plus y2 minus y1 the bracket square, or it can also be written as root of x1 minus x2 the bracket square plus y1 minus y2 the bracket square. And also you have seen, if I want to find the coordinates of any point P, if I want to find the coordinates of any point P which divide the join of A and B internally in the ratio m is to n, internally in the ratio m is to n, then we are going to apply the section formula. And the section formula for internal division. Here we are what we are finding? The coordinates of the point P. Here we are finding the coordinates of the point P which divide the join of the points A and B internally. Internally means it will be that point P. Internally means that point P will be in between the points A and B, and the ratio will be m is to n. So that coordinates of the point P, that I will be writing it as P of x, y. X and y are general. So that coordinates are given by, last year you have derived this formula also. So it is given by what? mx2 plus nx1 divided by m plus n, and then my2 plus my1 divided by m plus n. These will be the coordinates of the point P. So it is given by P of mx2 plus nx1 divided by m plus n, my2 plus my1 divided by m plus n. Then if this point, remember, if this point is not on the in between AB, but it is outside the point join of, and since it divides in the ratio m is to n, again in the ratio m is to n only, PB is n, PA is n, right? Then this happens to be external division. This happens to be what? External division, and the coordinates of those external division will be P of mx2 minus nx1 divided by m minus n. P of mx2 minus nx1 divided by m minus n, and my2 minus my1 divided by m minus n. This will be the coordinates of that point P. Now, what will happen if P happens to be, that also you have seen, what will happen if P happens to be the midpoint? If P, this is A of x1, y1, this will be P of B of x2, y2, and then P happens, P of xy happens to be exactly the midpoint. If P is the midpoint in between the points A and B, then P is going to divide. Then P is going to divide the join of the points. P is going to divide the join of the points A of x1, y1 and B of x2, y2 internally. It is going to divide internally in the ratio 1 is to 1. It is going to divide internally in the ratio 1:1, then the coordinates of the point P will be x1 plus x2 divided by 2, y1 plus y2 divided by 2. It is nothing but it is P of x1 plus x2 divided by 2 and y1 plus y2 divided by 2. This is known as the midpoint formula. This is known to be the midpoint formula. This is a very important, and midpoint formula, if you are going to apply, it will be only for internal division. It is only for internal division. Next that you have studied is, in the rectangular coordinate system, if a triangle is formed, in the rectangular coordinate system, if the triangle is formed, say A of x1 y1, B of x2 y2, and then C of x3 y3. These are the points here. A of x1 y1, B of x2 y2, and C of x3 y3. Then the area of the triangle ABC is given by what? 1 by 2 into x y minus y plus x into y minus y plus x into y minus y. So this will be 1 2 3 2 3 1 and then 3 2 1. This is the area of the triangle whose coordinates are given by what? A of x1 y1, B of x2 y2, and C of x3 y2. Remember, whatever the formulas that we have seen, the formulas are going to hold good in all the four quadrants. In all the four quadrants, whatever the formulas that we have seen, the formulas are going to hold good in all the four quadrants, right? So in the next class, these were the basics that we have studied. So in the next class, we will be directly moving on to the straight lines, right? Thank you.